Okay, guys, so let's continue on our discussion. So the big thing that I said I left something out, and that is that when we access a database, many times what we're doing is getting information, but we're also updating and adding information. We're inserting rows, we're updating information, right? And so the question is not just what's more work when we're getting information, when we're just getting, hey, how old is this person, right? But also, how often is this going to have to change, right? So take, for example, this example here, the age. So let's say the person's birth date is maybe it's tomorrow, the holiday, 19th of May, right? 19th of May. And let's say they were born in, let's do an easy number, let's say 2000. Okay, so they were born on the 19th of May, 2000. So as of today, they would be 20 years old, right? So 20 would be what would be stored here, right? But tomorrow, they're going to become 21, right? So here's the question. If we store this as a column, then what has to happen? We have to run an update statement tomorrow. Okay, we have to run an update statement to update this row tomorrow to be able to keep that data correct. Do we only have to run that update statement on May 19th? What do you think? Do we only have to run that update statement on May 19th? No, how often do we have to run the update statement? Do we have to run it on May 20th? Do we have to run it on May 21st? Every year on the, well, but what if somebody was born on the 21st of May? We have to run the update statement on the 21st of May, don't we? What if somebody was born on, like me, the 21st of June? We have to run the update statement on the 21st of June. We have to run an update to make sure that we catch every row in our table, keep it up to date. We have to run the update statement every day of the year, right? So we have to run this update statement every day of the year to make sure that the age stays consistent and true. But if we don't store it as a column, all right, 21 again. All right, if we don't store it as a column, if we store only the birth date, okay, if we only store the birth date column and we have our client or DBMS, we have these guys calculate the age when we need it, then we don't need to run any update statements because our core data, our actual underlying data in the table never changes because your birth date will never change. We just have to then write a code here. So what I'm getting at here, what I'm saying is that if we store it as a column, that makes it easier to calculate it when it's needed to be seen. But if we store it as a, if we don't store it as a column, that makes it much easier to keep the data consistent and up to date, right? As the days change and as stuff like that changes, okay? The thing is that in this example, I would agree. Yeah. Right. And so I would agree in this example, Tana, you're right on target to say that what we should likely do in this example would be not store it as a column. I would be very surprised if any system that keeps track of your age, the university system, the Turkish government system, uh, um, anything else that keeps track of your age, right? I would be very surprised if it stores your age as a column and doesn't just store your birth date and calculate your age, right? Because age is one of those things that changes frequently. It changes every year, and the data in the database table literally changes every day, right? Because someone's age in a large enough system, someone's age is changing every day, right? Because as long as you have, you have a few hundred people, you're going to have somebody that's going to have a birth date on every day. Like somebody in that group is going to have a birth date on January 1st. Somebody's going to have it on January 2nd. Somebody. So the data, something in there is changing every day. Okay. So it would not make much sense. And I'm going to stop sharing. How do we do this? Okay. So it would not make much sense to store something like age. Okay, it would not make much sense to store something like age as a column. That doesn't mean that that's always true. Right? There are examples where maybe the values don't change frequently. Right? The data doesn't change frequently, and it might make more sense to store the data as a column in other examples. But basically what we do is we kind of go through a trade-off calculation to say, okay, the option to store the derived data, meaning we have to have the additional cost of an the hardware space of an additional column, the software additional code requirements to calculate not the additional code requirements, the additional hardware space of the column, the additional code to keep the data up to date, to keep the data consistent, right? Versus the cost to calculate it each time it's required. What is the extra code? Because for something like age, it's pretty simple. You take today's date, you subtract their birth date, and you get their age. You're done, right? But there might be some other derived data that's much more difficult to calculate each time we need it, right? Okay, and whatever is less expensive, the cost to store the derived data versus the cost to calculate it each time we need it, whichever one of those is less expensive, we're going to choose that, and of course based on possible performance constraints, because additionally when we calculate the data it will take more time than if we were to just store the data directly. Because again, remember what we're doing is we're going out to the database, we're saying give me this piece of information. If the database or if our client has to do additional calculations, that's adding time. Microseconds, milliseconds, right? Not a long time, most likely. But depending on the size and the amount of calculation that's required, it could add up and cost more time. Okay, so again, there's not a one size fits all. There's not a one answer to this type of thing. But we will look at the cost of each, and whichever one is going to cost us less, that's what we're going to do. Okay. So an example might be how many properties is a staff person handling, right? And we would use this as an example of, we want to make sure that the staff is not handling too much, right? And so We could calculate this. We could option A, store this as a column, and every time a staff person, right? Every time a staff person takes on a new property, we add one to this column. Every time they stop managing a certain property, we subtract one from this column, right? So we keep this, we could store it as a column in our staff table. This might be the kind of thing that would not frequently change. And so therefore we might consider storing this as a column. The other option would be we don't store this as a column. We simply we create a view that calculates how many times their staff number appears in this table over here. Okay, so two different options. Store it as a column, don't store it as a column, and use the underlying data, in this case the staff number, how many times the staff number appears in this column here in this table, and use that underlying data as our calculation. Okay. Again, neither one is correct. Sometimes one is better, sometimes the other is better. But you do need to understand what are the costs associated with each way of doing it. Storing it as a column, easier to get the data when we need it. Harder to keep it consistent. Okay. Not storing a column, also storing as a column, additional hardware costs to keep that, to have that extra column in our table. Okay. Not storing as a column means less cost on the hardware side. We don't have to keep that table. We don't have to keep that column in that table. Less cost on not storing it as a column, less cost on keeping the data up to date, because we don't have to run update scripts every time the data changes. All right, every time not the data changes, every time that the derived data value could change. What was the last thing? Oh, but it costs more to calculate it when we need it. Okay, it just will. It may be marginal, maybe a small cost, but it is going to cost more to calculate that data when we need it. Okay, I'm going to speed through some of this, and we'll get to indexes, and we'll talk about what indexes are, and then we'll call that a day. Let's see. Am I analyzing transactions? A good thing for you to understand and look at, we won't go into it in detail here, but it is an idea of how we could use transactions to analyze our database. Okay, but indexes, the thing I wanted to get to and wanted to end on here was the concepts of indexes. Let me make sure there's nothing particular after this that I wanted to go over. I guess there's one slight discussion at the end of this too. But okay, so basically an index, what most indexes are used for is kind of like a table of contents. So if you had a book, like let's say a dictionary, and if you were to say, I want to find the word database, would it make sense to start at the beginning of the dictionary, first page, and say, is database on this page? Nope. Okay, flip to the next page. Is database on this page? Nope. Flip to the next page. Database on this page, and keep going through. No, right? That would not make a lot of sense, because database is not going to be in the A's, right? It's going to be a little bit deep into. It's not going to be quite in the middle, right? It's not going to be. It's going to be probably in the first fourth of the dictionary, right? But it wouldn't make sense to start at the end. It wouldn't make sense to start at the beginning. Wouldn't make sense to start right in the middle. It's kind of like, let's jump ahead a little bit and see where it is, right? So that's kind of how an index works. It takes a column. It takes a column that probably will be searched through. So like a primary key column, or maybe a column that has a specific set of possible values. So if you had like a gender column with male and female, if you had What else? What's something else that kind of generally kind of groups people? Well, if you're keeping track of all the people in Turkey and what their home address is, you might have you might group people by what city they live in, like Antalya, Ankara, Istanbul, Izmir, you know, all those different cities, wherever you might live, you might want to group that, right? And so an index helps us efficiently search through a column that we might there might be clustering. There might be like groups of people who live all in the same city. We might want to be able to sort based on that column, and an index will help us be able to do that quickly. Okay. And so that's what an index is primarily good for. Is now a primary key column will get an index on its own. In MySQL, when you say that a certain column or set of columns is a primary key, it puts an index on it on its own. Even though that is a unique column and there is no potential clustering at all, it's a different kind of index that helps us understand that each of these is going to be unique. So we want to be able to search through them and sort through them pretty easily and quickly. Okay, so this is what an index is useful for. Columns on their own do not come with an index. All right, so the system doesn't automatically assume that every column is going to need an index. So instead, what we would do is, if a certain column, if we know that a certain column will have groupings, like I said, the cities you live in, what gender you are, maybe if we do have an age column and that we store it as a static value, then or a specific value, then we might want to put an index on that column, because there could be clustering there. There could be a lot of 19-year-olds and a lot of 21-year-olds and a lot of 36-year-olds or whatever, right? And so we might want to put a clustering on that, right? Okay. And what that does is, when we put an index on a column, if it's a column that makes sense to put an index on, it can speed things up dramatically. Okay. In fact, sometimes I can remember in my last work position before I was teaching, that the DBA, the database administrator there, oftentimes would monitor the network traffic, monitor the traffic between the client and the database. And what he would find is that would be like, oh, this query over here is slowing things down. There's one query that just it's taking much longer than any other queries, and we want to figure out how to speed it up. We would look at the columns that were being used as part of that query, whether it be the select part or the front or the where part. And if we found that there was one column that maybe could use an index and it might help, what he would do is he would then put an index on that column, and we would run some tests to see if it sped up the query, and many times it did. But sometimes it actually made things slower. And the reason why is that if an index is put on a column that doesn't make sense, there's not clustering, it's not a primary key, it's not a unique column, right? And if we put an index on that kind of column, it can actually slow things down, okay? So we have to be very smart about how we choose what columns we put an index on. Okay, so some examples of the wish list of how we would want to index things. We're not going to index small relations, and small does not mean few attributes. Small is more few rows. If there's only a few rows, it's not going to take us a long time to search through those columns to find our value. So we don't want to index relations that have very few rows. Okay. We should definitely index the primary key. Like I said, in fact, MySQL automatically puts an index on primary keys, right? If a foreign key is frequently accessed, we should put an index on that, a secondary index to that, okay? Or any secondary index that's an attribute used as a secondary primary key, as an alternate key. Okay. Any attributes that are involved in order by, group by, join, right, union, distinct, anything like sorting, like distinct or anything like that, we should put an index on there, all right? Because if we're going to be grouping by, that's a clustering. That means we expect that that column will probably have some clusters, right? If we do group by, where we're saying, you know, look for the maximum salary amongst staff people that have certain titles, right? Or what is the count of students who are in each department, right? So then the department would be a clustering thing, lots of students in that department. The staff title would be a clustering thing because we'd expect there'd be groups of managers and groups of staff and groups of supervisors and whatever. Right, so if there's a group by, we expect there to be clustering, we should put an index on there. Okay. Some others, so these 5 are kind of the main big ones that we want to definitely index on things. Built-in functions. We want the other one. These other ones. Let's see. Okay, and then some of the avoids. 6 and 7 aren't so important, but 8, 9, and 10, right? We avoid indexing an attribute that is frequently updated, right? That if an attribute frequently changes, we want to consider, we don't want to really index that, because what an index does, when we first put it on a table, it goes through and looks at what's there and kind of like if you had a table of contents for the dictionary, right? And you would say the A's start on this page, the B's start on this page, the C's start on this page, the D's on this page, and so forth, right? The index goes through and kind of makes this understanding of how the data is laid out. Okay. Now, if the dictionary was constantly changing, which it's not, right? Every few years they release some new words or take some old words out of circulation, but for the most part, right, it stays the same, right? And so since it doesn't update frequently, we can leave that kind of that pagination, that where the different pages are, where the different starting points are, kind of intact. But if the attribute or relation is frequently updated, it's constantly, D is constantly changing. It starts on page 28, now it starts on page 30, now it starts on page 29, and it's just every day it's changing like that. The index becomes useless, right? Because the way it created that kind of table of contents, that stuff is no longer valid because the data has changed. Okay. A good index also will do every once in a while, it'll revisit what the data looks like to create that page stuff again. Okay. We want to also avoid indexing any attribute if we're going to get a large proportion of those, so a lot of rows. If we go to query a particular table and one attribute will get us lots of data. Okay, so for example, if we wanted to trying to think of a good example here. If, let's say you had in the university system here students and one of the attributes was their nationality, maybe, right? We might not want to index that because even though there is some clustering, there's a large group of Turkish nationality students, there's much smaller group of other nationalities, right? And so it might make sense, and I don't know, that's just a guess on my part. I don't know how many Turkish students we have as compared to other nationalities, But if that query will result in a large proportion of the relation of the rows, then it probably is not a good idea to index that column. Okay, and one big one too is long character strings just are really hard to search. They're hard to deal with. There's a lot of stuff they're hard to do with, and so we don't index long character strings. And the reason why here is because of how many different possible representations there can be, right? So, and when I say long character strings, like a few characters, if like, for example, if we stored the phone number as a string of 10 characters, that would not be considered a long character string in general. But if, let's say, we had people's addresses, right, and your address was a long character string that consisted of everything: your street, your building, your DID number, your city, your mahalle, your zip code, everything's all included in this long character string. All right, we would not index that column. Now, what we might do is, if we store people's addresses as kind of sectioning those things off: country, city, mahalle within that city, what street they're on, and if we kind of like broke it up into those pieces, yeah, okay, index their city, absolutely, right? Because that's a clustering thing, and it's not like, it's not like 70% of the population all lives in one city, even though Istanbul is huge, right? It's not 70% huge, right? But we would index their city, and we would index their mahalle, and we would index those things that could result in clustering. Right. Okay. All right, and then where we'll end today. Well, two more slides. One is we will want to estimate the amount of disk space that will be required, because we'll want to know what size server do we think we'll need. Okay, and a bad estimate could result in lots of problems, right? One, if we estimate too small, we get the server in there, and maybe it works great. Maybe our estimate is we need, a 1 terabyte server, and we go get a 1 terabyte server, and we use up, like, in the first day, and we go live the first day, and we're using about 80% of that server for our database. Well, it works the first day, but what happens if in a few weeks' time we use much more of that server than we initially thought? Right? Now we're going to be looking at, now we got to go buy a new one, right? Okay, so that could be an issue. If we estimate too large, we say we need a terabyte server, we go live, and we're like, we're using like 1% of this thing. Right? Then what happens? We've wasted probably money on a bigger server than we absolutely really needed. Okay, so we want to estimate well, but we also don't want to just estimate what we need right now today. We want to also keep in mind that our system may grow, and we will want to be able to be prepared that it could grow and we would need more later. Okay, so we want to keep an idea of not only what do we need today, but also what will we need 6 months from now? What will we need a year from now? What will we need 5 years from now? Right? And know that yes, maybe in some period of time we may need our system may grow to the point that we need to buy new hardware, and that's okay. But we want to make sure that it's not so soon that we feel like we wasted our money today. All right. And then final slide here is we want to design user views and security measures. Now, more than anything, this class is not, again, a user interface class, nor is it a security class. So we won't go into detail here, and I'll end here. But it is a matter of that we need to keep these things in mind. We need to be thinking about that the user is going to be using our system, and we need to be prepared for that. And we need to have an idea of how they're going to use it and how we can give access to the right things to the right people. And we want to also be aware of security measures, right? And we want to make sure that Passwords are stored securely. We want to make sure that access to the system at all is done well to make sure that only people who are authorized users are able to get access. Okay. All right. So we'll end there. Let's see. One thing. Let me say. That's not you. All right. So again, we will start on Monday doing group presentations. If I don't have any volunteers, then I'm going to run a random number generator to decide which one of you gets to go first. So everyone needs to be prepared on Monday. Okay. I will send out this week. I will send out a Google. Sorry, not a Google. A Microsoft form that you will use as someone who's attending the other group's presentations for you to kind of rate their presentation. You remember, this is part of your grade. Though the results of those forms will not be used to grade the presenter. The results of those forms will only be used to grade the person who's attending, so the viewer. Okay, because I want to make sure that you guys are all paying attention well to the presentations. Remember, everyone in this class has worked hard on their presentations, on their projects, and so I want to make sure that we give them the honor and respect that they are due when their presentation time comes. But for those of you who will be presenting, you can use the form that I'm going to send out as kind of an understanding of the things that I'm looking for, the things that we're expecting you to present, the things that we're expecting you to show us. Okay. Let's see. I think that's it. So other than that, we'll do group presentations, and again, keep them to 30 minutes total, right? That's all I can give everybody. That's all I can give everybody is 30 minutes max. All right. So what we'll do is, and what I would prepare for if I were you, is I would prepare for 20-minute presentation, 5 to 10 minutes worth of question and answer. All right. And then assuming that means that we'll have 1/2 hour left over at the very end of this semester, I will save that for a final exam preparation and some final notes. Okay. All right. So thank you guys so much. I look forward to seeing you on Monday, and have a good holiday tomorrow. So, I mean, you would say what, Beidamen is Kutlolsen, or, I mean, is there something special to say for Genschlik Vespoor Beidam? Or is it just Beidamen is Kutlolsen? I don't know. So, all right. Thank you guys. Oh, I think I got an answer. All right. So, guys, have a good holiday. We'll see you when we get back on Monday. All right. Have a good afternoon.